Okay, in this particular problem, they are giving you sigma notation for a function. They want you to find the interval of convergence. There's only two ways you can do this. Either it's a geometric or you use the ratio test. I noticed that it's not geometric because everything is not raised to the nth power. So I'm going to use the ratio test here. So step one is set up your ratio test. So everything to the n plus first term. If I do n plus 1 here, the minus 1 drops out, so that's that. Divided by the nth term, so just go ahead and flip the original. And I know, since I am taking the absolute value of this, this will just become 1 anyway, so it really doesn't matter. Let's simplify a couple things. Notice the 2x to the n will drop out with one of the 2x to the n's here, so you're left with 2x here. The n minus 1 is still on the top, the n is still on the bottom. So now if I take that limit as n goes to infinity, the degrees are the same, so this limit is just absolute value of 2x. It only converges if that limit is less than 1. Solve this inequality. Okay, there's my first step. Now they are asking for the interval of convergence, so you must check your endpoints. So I'm going to start with x equals 1/2. So I'm going to take that x value and plug it back into the original sigma. I want to know what happens when x is exactly 1/2. When I do that, what happens to the sigma is 2 times 1/2 is 1. 1 to the n is always 1. So I don't even need to write that. I end up with this. Okay, when I see that, you should be thinking alternating series test. You can check your two conditions, but I know that absolute value of numbers decrease to 0, so you can write it like this, or show that the limit is equal to 0 and that the n plus first term is less than or equal to the nth term. So I know this converges by the alternating series test. Okay, let's check x equals -1/2. So if I do that, notice here, if I plug in -1/2, this becomes -1 to the n here. I'm going to simplify this a little bit. -1 to the n and another -1 to the n. We'll end up with -1 to the 2n, which is always positive 1, so I can simplify to this. There's a couple ways you can do this. You can do the integral test. The integral of this will be infinity, so it diverges. You can do a comparison test. I know that this is a p-series that diverges, so you can do the limit comparison test. If I take the limit of 1 over n minus 1, this is equal to 1. As long as you get to the same real number, they will both do the same thing, so I can say this also diverges by LCT. So a couple different ways you can go. So your final answer for your interval of convergence is that it is going to diverge at -1/2 but converge on 1/2. So this should be your interval of convergence. Part B. Show that y equals f of x is a solution to this differential equation. So they want you to show that this is a true statement. Okay, again, there's a couple ways you can go about it. I'm going to go kind of the method that's probably the most straightforward. So I'm going to somehow try to figure out this and see if it matches to this function. So let's start. So f of x is the only thing that you know. You know that f of x, which is y, is equal to this sigma. Okay? So I'm going to go ahead and start building this series. Let's come up with the first couple terms. So the first n value here is 2. So if I plug in 2 into n, this is a positive 1, this is 1 on the bottom, you end up with 2x squared over 1. Let's go to the next term. So go ahead and plug in n equals 3. You'll notice that it'll be a minus sign. It'll be 2x to the third. The bottom will be 2. So again, do this for the next couple terms. And this pattern continues, etc. Okay, I'm going to multiply this out. So this is really 4x squared minus 4x cubed plus 16/3 x to the 4th, ... Okay, so this is y. This is the first couple of terms of this infinite series. What I'm trying to do is figure out what this is. So this is xy prime minus y. I need to come up with y prime because I need it here. So y prime is going to be 8x minus 12x squared plus 64 over 3 x cubed minus dot, dot, dot. There's more terms, obviously. Okay, let's come up with xy prime. So if I take these terms and multiply each term by x, which will give me xy prime, this becomes 8x squared. This is 12x cubed. This is 64 third x to the fourth minus dot, dot, dot. So I have this piece now, xy prime. Now I need to take all of this and subtract off the terms for y. So xy prime minus y. So I'm going to go ahead and collect like terms. So here's xy prime, here's y. I'm going to take this and subtract off all of this. Notice these two terms are like terms, so my first term will be 4x squared. Notice these two terms are like terms, so if I take this and subtract this one, this will become a plus, so my next term is this. Same thing here. This, subtract this one off, I'm going to end up with 16x to the fourth, so the pattern continues. Okay. Notice I'm trying to show that this is equal to this. Do you notice that this function is written in the form a over 1 minus r? Do you notice here your a is 4x squared? Okay? And what are you doing every single time to get to the next number? Your r is negative 2x. So this is 4x squared over 1 plus 2x. So you're showing them this is really this geometric series.